Well, good evening, AP Physics students. Mr. Kirsten coming at you here, starting a new unit today on statics, talking about equilibrium. So apparently in this world, when you build things like buildings, it's very important that they not fall over. So in college, if you're going to be an engineer or a physicist, you might take an entire class about Chapter 9 called statics. And basically, statics all comes down to two equations, and here they are. So if something's at rest and staying at rest, two things must be true. Number one, the net force on it must be zero. And number two, the net torque on it must be zero. Now notice that one of these things does not necessarily imply the other. For instance, this pen right here, the net force acting on it is zero because its center of mass is staying right where it's supposed to stay, in the center there, but yet it was spinning, so the net torque must be zero. So sometimes students mistakenly think that one of these implies the other. It's not always the case. So for something to be in equilibrium, it must be at rest and staying at rest. And these two conditions must be met, and that's probably the shortest lecture you'll get all year. So really, this chapter is about applying these equations a lot to a lot of different situations and learning how to solve problems with them. So the first problem we're going to solve tonight is problem number 6 here. And we'll show you a picture here. It says calculate the forces F sub A and F sub B that the supports of the diving board in the figure represent when the person stands out on the front. So here's our figure. We got a person on a diving board. We've got two supports. The person's 58 kilograms, and we want to know what forces these two supports exert. So for instance, if you were going to build a diving board, how strong would you have to build it? What kind of forces would those supports need to be able to maintain? So I've got my picture drawn here. I know that the mass of the person there is 58 kilograms. I know my distances here, 3 meters and 1 meter. I know the mass of the board. Now, in part A of this problem, it says ignore the mass of the board. In part B, you're going to take that into account. And then it says, what is force A and force B? So we might want to just take a minute here and try to think to ourselves, well, if this person's standing there, what might these forces look like? And I think if you think about it for a while, you'll come up with the idea that F sub B must be going this way. That is, when the person stands out there, this part's pushing up. And A is really pulling down, okay, like this. And anyway, if we can get these three forces to equal out, then we should be able to get a diving board that is in equilibrium. That is, the net force acting on it must be zero, and the net torque acting on it must be zero as well. So for part A of this problem, we're going to assume that the diving board itself is very light. So it says we can ignore the mass of the diving board. And then it says, what would FA and FB be? We're going to go ahead and get to work. Well, let's think about what we know here. We know that both these equations are true. Now, I don't know either F sub A nor F sub B, so while it's true that these three forces must add up to be zero, the fact that I don't know two of them doesn't really lend me to solving an equation I can solve. So number one here may not be the way to go. On the other hand, if I imagine a pivot point right here, that kind of makes this torque be zero. So I'm going to try to use this torque equation with my pivot point being at point A here. All right. So if I calculate the net torque of point A, what I would get is F sub B would exert a counterclockwise, right, or positive torque, right? And then the person's mass out here would do a clockwise or negative torque. So if I do my torque equation, the force times the distance between where the force is applied in the pivot arm here, right? I would get F sub B times 1 for the torque that this pillar is exerting, and then the torque that the person, by way of their weight, is exerting would be equal to the mass of the person times G times the length of that moment arm, which would be 4. So if I rearrange things here a little bit, I just get that this torque is equal to that torque, at least in magnitude. So rearranging here, I get that the force that pillar B here exerts on the board is 2,300 newtons upwards. That's rounded a little bit using significant figures there. Should be 2 significant figures in our answer. Okay, so I'm halfway done with part A here. So how about part B? Well, now that I know 2 of the 3 forces involved, since I know this diving board is not accelerating upward into the air, I know that the net force on the diving board in the y direction must be 0, right? Therefore, if I add all of these up, they should add to 0, right? Not a bad equation, right? No torques to figure out or anything like that. This is just going back to trimester 1 here. It's at rest, it's staying at rest. The net force on it must be 0. So if I just do some algebra here and rearrange a little bit here, I get that F sub A must be 1,700 newtons downward. All right. Again, just adding them up here. Net force must add up to 0. So for part B of this problem, we're going to let you guys figure that out at home on your own. The only hints I would give you here is that when you take into account both the force of the board and its torque, what you would do is you would assume that the board is uniform, so its center of mass would be right in the middle at 2.0, and of course its weight would go straight down. So again, you would have to do some calculations there using these 2 equations to figure out now what these forces are. Forces are going to be a little different, but it's just using these 2 equations and this free body diagram here, and it'll get you there. So work on that tonight. If you have questions, come tomorrow. And for your hard work today, we're going to give you some Pez out of the Death Star Pez dispenser. A little bit dated, both the Death Star and the Pez there. And we'll tell you a joke too. Hey, did you hear about the guy who ended up in criminal court for trying to put dynamite inside a steer? It was abominable. A bomb in a bowl. Get it? A bomb in a bowl. That joke was the bomb, which is something people used to say many, many years ago. Anyway, good work, AP Physics students. Finish up part B, and we'll see you tomorrow.